So in this video, we're going to talk about how to find domain of a logarithmic function. So we all know that logarithms are these functions. So we have, say, f of x is equal to some log base a of x. And when you draw this function, it looks, so we're assuming a is greater than 1. So the graph of this function looks something like this, right? So it passes through the point 1, 0, and we know that it has a vertical asymptote x equals 0. So from the graph, we know that the domain of this function is set of all x such that x is greater than 0. So we know the domain will be 0 to infinity, open at 0 because 0 is the vertical asymptote. So x equals 0 is not defined for logarithms. And we know the range of this function is all real numbers, so it's negative infinity to infinity. So based on that knowledge, we say that the domain of a logarithmic function is the set of all positive real numbers, okay? So how do we find domain of more complicated logarithmic function? For instance, what will be the domain of the function, say f of x is equal to log base 4 of x plus 3. Of course, we can use transformation to graph this, but you want to do it algebraically to figure out the domain. So the domain of f consists of all x for which x plus 3 is greater than 0. That's how you would solve it to find the domain. So we take what inside the logarithm and solve it as a strict inequality. And then if I were to solve this, I would go ahead and subtract 3 from both sides. And we have our domain, x is greater than negative 3. So the domain of this particular function, it's going to be open at negative 3 to infinity because we want x to be greater than negative 3. Let's try another one. So let's go ahead and find the domain of this function. So we have f of x is equal to negative log base 5 of 3x plus 2. So again, the idea is we want to solve the inequality by taking what's inside the logarithm and setting it greater than 0. So we take 3x plus 2 greater than 0 and solve for x. So subtract 2 from both sides. That would give us 3x greater than negative 2. And then we divide by 3 to isolate x. So that would give us x is greater than negative 2 over 3. So as long as x is greater than negative 2 over 3, this function is satisfied. So the domain of this particular function is going to be, again, open, negative 2 over 3 up to infinity. So that will be the domain of this given function. Okay, let's try one last example. So let's do h of x is equal to 3 minus log base 2 of 5 minus 2x. So let's go ahead and find the domain of h of x. So again, we do the inequality, so we take what inside the logarithm and set it greater than 0. So we have 5 minus 2x greater than 0, and then we subtract 5 from both sides, because our goal is to isolate x, so we have 2x is greater than negative 5. And then we divide by negative 2. Now here you have to be careful. Every time you divide or multiply by a negative real number for an inequality, you must switch the sign of the inequality. So now our greater than becomes a less than. So we have x on the left, and on the right side we just have 5 over 2. So that's the inequality notation for the domain. So hence we have the domain of h, which happens to be everything less than 5 over 2. So that would be negative infinity up to 5 over 2. So that would be the domain of h of x.